Hello friends, welcome to Satpute Academy. Today we'll study how to write a C++ program for creating a linked list. So our linked list will be contained in an object which will look like this. This will be an object containing our linked list. Let's call this object L. Initially the linked list, there is no linked list, the linked list is empty, so the object will contain only a pointer which is pointing to null, that is first pointer. So initially there is no linked list inside this object L. Linked list is empty, that's why this first pointer which will be pointing to the first node of the linked list will be null. It is not pointing anywhere. That's how our linked list will look like in the beginning. But as we build the linked list, the object will look like this. The object will look like this. We'll have the linked list here, and first pointer will be pointing to that linked list. So that is how our linked list, our object will look after building the linked list. So now here what I require two things. One is a class to create this object. And other is a class or structure to create this node. Other thing which I require is a class or structure to create this node. So I require two data types. One is a class to create this object L, which contains, this object L contains only first pointer. These nodes are created dynamically by demanding memory. They are not there in the beginning. So this object contains only one variable, that is this first pointer. So we'll require a class which contains only one variable called as first, which is the pointer of the structure node type, right? So that's the first thing which we'll require. And the second thing is the node type structure, this node type structure to create this node, right? So let us write the class and structure required for creating this linked list. So first thing I require is a structure. So struct node. Inside this struct node I have two things. So here if I show you, so this first part will contain data. That data may be as simple as an integer or as complex as any complex record. So this is integer here, and this is the pointer which will be pointing to the next node in the linked list. So this type of pointer is node. So these are the two things inside this node. So struct int data, this first part, and second thing is the pointer of structure node type, struct node star. Let us call this pointer as next. That's the structure which I will require. Second data type which I'll require is a class, right? So let us write this class. So class linked list, right? Inside this class I have only one variable called as first, which is a pointer of structure node type, struct node star first, right? Now as soon as we create this object of LL type, we want that first to be null. So that's why I will write a constructor which will set this first to null as soon as the object of this class is created. So let us write the constructor public. So LL, so this LL constructor will set the first pointer of the object to null. Null means it is not pointing anywhere, right? Now I want a method which, when I call on this object, right, this is the object of LL type, right? So this first will be set to null when you create this object L by saying LLL. How will I create this object? By saying LLL, right? So L is of type LL. So as soon as this object is created, this constructor will invoke on this object and will set this first to null, right? So now what I want to do is, on this object I want to call a method called as create method. I want to call this object on this object, and this create method will create this linked list inside this object, right? So I'll declare this method here. So create, void create. So this create method will create the linked list inside this object. Now in order to print this, we will define this method outside of this class. So in order to print this method, we will call a print function, void print, and this print function will run on this object and will print the linked list. So that's it inside the class. So that is the class definition for creating such object. Now let us write the create method and print method. So here is the create method, void create. So inside create I'll take one pointer of struct node type, which will help me to create the linked list. So struct node star p, that p will help me to create the linked list. Then I'll require some variables, int n for total number of nodes and I for looping purpose, right? Now I will ask the user cout how many nodes are there, nodes. User will say there are n nodes. I'll store that value entered by user in variable n. Now when user said there are n nodes, my job is to create the first node. So for that I'll demand memory. For creating first node, I'll demand memory by saying first is equal to new node. So this statement will allocate the memory for node type of data. New will allocate the new memory. Memory will be allocated dynamically. We do not have that memory. Our object is looking, our object is this. If this is LL object, so first is null initially, right? When we say first is equal to new node, memory for new node will be allocated, and that will be pointed by first pointer. Then we'll set as there is no next node, we'll set this next pointer to first. So how can I access this next pointer? By saying first arrow next is equal to null. There is no next node, that's why we are setting this next to null. Now we'll ask the user enter the data for first node. Cout enter data for first node. User will enter data, and that data has to go in this field, data field of the structure pointed by this first pointer. So I'll see in first arrow data. Arrow is the operator used to access the contents of the structure pointed by a pointer, right? So now we have created first node. Let's say user entered 10 here, we store 10 here, right? So now we have to create the remaining nodes, right? For creating remaining nodes, I'll take help of the pointer p. I will not move first pointer from the first node now. I'll take p and use p to create the remaining linked list. So I will initialize p pointer to first. P is equal to first. So here is our p pointing, right? P is pointing here. P is pointing where first is pointing. Then my job is to create a remaining linked list, right? So I will create the second node like this by demanding memory by new node, and that node will be pointed by this pointer. Name of this pointer is first arrow next. So I will be writing a statement p arrow next or first arrow next. I'll use p arrow next is equal to new node. So this will create a new node, and that will be pointed by this p arrow next pointer, right? Then as I don't require p here, I will move this p to this location which is pointed by p arrow next pointer. I'll simply say p is equal to p arrow next. Right. Now I am on this location. I'll ask as there is no next node as of now, I'll set this next pointer to null. So p arrow next is equal to null. Now p has moved from this location to this location, that's why this pointer is now p arrow next. So we have set this to null. Then I will ask the user to enter the data for this node. So cout enter data for next node. Okay, user is going to enter the data and that data has to go here. That data has to go in this part. This is called as p arrow data. This part is called as p arrow data. So in p arrow data. So data will go in this part. This is c arrow data. Let's say user entered 20, right? So that's how we created the second node, and we attach the second node in the linked list. Then in order to create the next node, I will demand memory, right? And I'll point that memory by this pointer, which is p arrow next again. So the statement will be p arrow next is equal to new node. I'm going to write the same statement. I'm going to write the same statement here, this one. Then I will move my p from here to here. So I'm going to write again p is equal to p arrow next. Then I'm going to make this next pointer of p null. So p arrow next is equal to null, right? Then I'm going to ask the user to enter the data for next node. I'm going to write the same statement, right? And then user will enter the data and that data will go here in p arrow data, right? I'm going to write the same statement, right? So I repeated the same statement, and for the next time also I'll repeat the same statement. So that means for creating node number 2 onwards, this is node number 2, 2 to n, right? I will write the same set of statements. So that's why I'll put those statements in a loop for I assigns to 2, because for node number 2 onwards, 2 I less than equal to n I plus plus, I'll repeat these statements, and these statements will create a linked list for me, right? So the linked list will be created and it will be there inside the memory, right? Now, so this was the function which this function belongs to the class. So we have to mention that. So let me write this. So this function is belonging to a class. So return type is void. The name of the class to which it belongs to is ll, and name of the function is create. So we declare this function inside the class, and we define this function outside of the class, right? Okay, now let us see the print function. Void print. Again, void, this print also belong to ll class. Print, this is scope resolution operator, and name of the function is print. So inside print, I'll take a pointer p to traverse the linked list. Struct node star p, and p I initialize to first. First p will be pointing to the first to the location where this first pointer is pointing, right? Now if p is pointing to some node, I'll print the data at that node, and I'll go on printing this, and I'll go on doing this till p becomes null. So this is the linked list here. This was first, this was object L, and I have taken p here. So if p is pointing to the node, I'll print the data at that node, and I'll move p to the next node. If p is pointing to a node, I'll print the data there, and I'll move p to the next node. Print the data, move p to the next node. Print the data, move p to the next node. And now here p becomes null. I'll stop that point at that point. That means while p is not equal to null, print cout p arrow data, and p is equal to p arrow next. So eventually this p will become null and we'll quit this loop and we'll stop printing the linked list. So this is the print function. Now let us write the main function to main function in which we'll create the object of the class and we'll invoke the functions. So here is our main function. So int main so inside main we have this first thing which we'll do is we'll create an object of class LL. L is the object of this class LL type. As soon as L is created, the first pointer in L will be set to null. Then on L we'll call this method called as create, L.create. This create method will create the linked list inside this object L. Then we'll print the linked list by calling print method on object L, right, and return 0. That's it. That's the simple main function. So that's the simple linked list program creation in C++. Now let us see let's execute the program in the editor, C++ editor. So here I am on the C editor. So here is this structure node, right, and this is the class LL. Inside this class LL you can see we have taken this first pointer and we have this constructor, create method, print method, and here is this create method which we have. So I wrote the same code which I explained on the whiteboard. So LL print method is here and here is this main method. So let us run this code. So how many nodes are there? Let's say there are 5 nodes. Enter the data for first node, let's say 10, 20 for second node, 30, 40, 50. So this is the linked list which is printed by print function 10, 20, 30, 40 and 50. Okay, that was the linked list program in C++. Thank you for watching.